Hello friends, welcome to my channel. In this video we are going to build a project automatic night lights using LDR sensor and Arduino. So if there is a light, the LED will remain turned off, and if there is a night time, then LED will automatically turn on like this. If I turn off the light, the LED will glow, and if I turn on the lights, that means the LED will on. So the components that are required for this project are Arduino Uno, breadboard, some jumper wires, few LEDs. You can use any number of LEDs, a resistor, and two LDRs. One this and other one is this. So I will show you two kinds of circuit, one using this LDR and other circuit using this kind of LDR. Basically it is a photoresistor. So same kind of principle are used in both kind of LDRs. Now let us quickly understand the difference between this photoresistor and this LDR sensor. So you can see at the top of the LDR sensor there is a photoresistor. So the basic working principle of both are same. So this photoresistor changes its resistance when the light falls over it, and it possesses high resistance in case of dark area and low resistance in case of light area. And we need one more extra resistor to connect in series of this photoresistor, because if we do not connect this resistor, what happens? The Arduino cannot read the resistance level of this photoresistor. The Arduino reads only the voltage level. So by using this resistor in series with this photoresistor, we can convert the resistance value into the voltage levels. Only then the Arduino can read the voltage levels of this photoresistor. So you can see this LDR sensor has three terminals, right? One for the VCC, other for ground, and other for the signal pin. So this circuit also has three terminals. One is the leftover leg of the photoresistor, one is a common junction between the resistor and the photoresistor, and the other leftover leg of the resistor. So what happens? We can connect the signal wire between the common junction of this resistor and photoresistor like this. So this wire acts as a signal wire, right? And we can connect the ground to the leftover leg of this resistor and VCC to this leg of the photoresistor. So now in this way we have three terminals corresponding to this LDR sensor in this case also. And we need to set the threshold value of this photoresistor manually in the code which we will write for this project. So I will discuss what is the threshold value later on. Now let us come on to the LDR sensor. So you can see this LDR sensor has a built-in resistor, right? So the resistor which we connect externally to this photoresistor, we do not need external resistance in case of this LDR sensor. So this entire PC board has inbuilt resistor like this one, right? And the threshold value can be set using this potentiometer by rotating this knob like this, right? So this potentiometer is used to set the threshold value. So this is a very compact form of the LDR sensor, or you can say the basically photoresistor, right? Now let us quickly understand the concept of the threshold value. So the threshold is nothing but the cutoff value for the light intensity level falling on this photoresistor or this LDR sensor. So if the light intensity is less than the threshold, it is considered as the light area. That means you can say or the bright area. So in this case the LED should be off. And if the light intensity is greater than this threshold, the LDR sensor consider as a dark area. So in that case the LED should be on. So this is the concept of the threshold value in case of LDR. Now we will start building the circuit. So first of all we will use this LDR to make the circuit. So let us keep this LDR aside and let us place this LDR on the breadboard. So first of all you see this LDR has three pins. This one is for the signal pin and other two are for the ground and the VCC. So let us place the LDR on the breadboard and take a jumper wire connected to the signal wire of the LDR, and take two jumper wires connected to the VCC and the ground of the LDR. So middle pin is the ground pin and the right pin is the VCC like this. Now let us place the LED also. So connect the negative terminal of the LED on the negative rail and positive terminal on the other side. Take another jumper wire, connect it to the ground of the Arduino Uno, and other end of the jumper wire connected to the negative rail of the breadboard to power the LEDs. Now this is the signal wire of the LDR connected to the analog pins like A5. Now the question arises that why we are connecting the signal wire of the LDR sensor on the analog pins and not in the digital pins, because the LDR sensor senses the continuous change in the brightness level of the light. So you see this LDR sensor has an IC on its board. So what this IC does, it changes the continuous change in the brightness level of the light falling on this sensor and change that brightness level into the continuous analog signals, right? So that is why we are using the analog signals. And because the change in brightness level of the light is an analog signal, that is why we use analog signals and not digital ones, right? So we are completing. Now connect this brown wire, which is the ground of the LDR sensor, into the negative rail of the breadboard. And this positive terminal will be going into the 5 volt of the Arduino. So this is the 5 volt pin of the Arduino. Now we are done with the circuit. Now let us move on to the second kind of circuit, in which we will use this photoresistor. Now we will make another kind of circuit using this photoresistor and this simple resistor. So please note that there is no negative or positive end of this LDR because it is just a resistor like this one. So place the LDR on the breadboard. Now we will connect the resistor to one leg of the LDR like this. Now take another jumper wire and connect it to the common junction of the LDR and the resistor. So we will connect one end of the jumper on the common section of the resistor and the photoresistor like this. And other end will be connected to the pin number A5. So this wire will be acting as a signal pin. Now we are left with the positive and the negative end of the LDR. So we will take two jumper wires, one for the VCC. So VCC will be connected to the other leg of the photoresistor. So connect it in the another leg of the photoresistor. And this brown wire will be connected to the other side of the resistor. So this is the circuit connection you can see. Now place the brown wire in the ground of the pin of the Arduino, and this red wire will be connected to the 5 volt of the Arduino. Now we are done with the circuit of both the circuits. Now we are left with the program of the project. And one mistake I observed while working with the LDR sensor is that most of the people don't connect this resistor in series with the LDR sensor, or they totally ignore this resistor. And what they do, they connect one of the legs to the Arduino pin and other pin to the ground or the VCC. So because of that, what happens? The internal circuitry of this LDR sensor gets damaged, or in some cases, the LDR sensor does not give proper reading of the resistance to the Arduino. So you need to keep in mind to put this resistor in series with the LDR sensor for proper working, right? So here is a program for our project. We are defining two pins here. You can see one for the LED and other for the LDR sensor. And as the brightness level of the light keeps on changing, we are storing those brightness level of the light into the LDR value variable. And we are keeping the threshold as a 500. And in this line, we are reading the state of LDR pin and storing that state into the LDR value variable. And if the LDR value variable is greater than 500, the LDR sensor will consider it as dark and the LED will turn on. Otherwise, the LED will turn off if the LDR value is less than 500. So I hope this code is clear to you. If you enjoyed this video, like and subscribe to my channel. And if you have any doubts regarding this project, comment your doubts in the comment section and we will meet with a new topic. Till then, goodbye.